Hello, I hope everybody's having a good day so far. I apologize for not being there, but influenza has hit my house and hopefully will not spread to any more people, but I am home with the kids because their grandma's sick and can't watch them. So anyways, I left this packet for you to do. I want you to work in groups for the first part. So essentially what you're doing is you're given a property there. It's x squared minus y squared is x plus y times x minus y, which is something called factoring difference of squares, which you learned several years ago. What they're going to do is, since it's an identity, they want you to kind of verify it using a variety of different numbers. So there's a prediction there, and then there's a table, and you can pick any two numbers you want. Please pick positives, negatives, whatever you need to do. And when you simplify, make sure you do order of operations. Your answer should be yes for all of your examples there because it is an identity. Okay, so it's kind of like a theorem. We know it's true all the time. Here, an identity is a specific type of equation. Many equations are not identities, however, because an equation is not necessarily true for every value involved. Of the 8 equations that are on here, only 4 are identities. Label the ones that are identities, and then if they are not an identity, show an example of when they would not, or counterexample for when it would not work, that to show it's not an identity. And some of these actually include some very common mistakes that we see in algebra, so be really careful with those. So 4 are identities, 4 are not identities, so give me an example of why it doesn't, or when it doesn't work. Okay, we've been talking about the unit circle a lot, and in this unit we're going to investigate trig identities. This one, we actually look at Pythagorean identities, which are 3 of the most commonly used identities, and we get them from the Pythagorean theorem and the unit circle. Okay, so we have the unit circle diagram here. Quadrant 1, we have A, B, C there, we have angle theta, we have the point x, y. So if we wanted to write out the Pythagorean theorem, you should have written a squared plus b squared equals c squared, right? So here's where we're at. Okay, I have a triangle here. Pythagorean theorem is a squared plus b squared equals c squared. Pretty easy, right? Remember that the ratio for cosine of this angle is adjacent over hypotenuse, so a over c, and the ratio for sine of theta is opposite over hypotenuse, so b over c. Okay. We're going to continue on, and this is the part that's teacher-led, but I want to make sure you have that all right. So we're going to use substitution and simplification and combine the 3 equations from parts A through C into a single equation that's only in terms of theta. So here's what I want to add here. Remember that cosine is also your x value in your point here. Okay, and your sine is also your y value. Okay, so remember A is x, B is y, C is actually 1. So in the unit circle, we're actually going to use x and y there. So instead of a squared plus b squared, we are actually going to plug in x squared plus y squared equals 1 squared. Okay, so those are actually the lengths of the sides based on that diagram. And we know that cosine is the same as x, and sine, I'm going to use theta there instead, let me change those, is the same as y. Back to purple. So cosine of theta, sine of theta squared, and then 1 squared is just 1. Now, here's what I'll show you. The actual Pythagorean identity that is most common is cosine squared of theta plus sine squared of theta equals 1. These are the same. We just like to avoid writing parentheses as much as possible, so that's why we put the square with the sign instead. Okay, so here's your Pythagorean identity. Now, working through this, you're going to pick an angle in each quadrant and kind of verify that it's true and see if it works out. You can use your calculator for this. Again, there's a note about mathematical notation. Then you're going to use your quotient identities. Remember, tangent is sine over cosine, cotangent is cosine over sine, secant is 1 over cosine, and cosecant is 1 over sine. Go ahead and take that original Pythagorean identity, divide by cosine squared on both sides, and then simplify it. And then you're going to do the same thing, but divide by sine squared and simplify. And then you're going to kind of fill in some more values here just to see how those work out. Okay, so just kind of verifying those identities. You should be able to do this in groups. Okay, I just wanted to make sure I had that teacher-led portion in there for part D, which I don't know that you probably need much help with that. But if you have any questions, let me know. I will hopefully be back tomorrow. Have a great day.